Hello, students. In the previous class, we have learned about a flat slab with drop and with column head. Here, we are studying about a flat slab uh, without a drop and without column. It's a bit hectic process. I'll go through the steps. So first, we do is we preliminary dimension the slabs and preliminary dimension in the sense we calculate the depth of the slab. Then we calculate the depth in a longer span. Then we calculate the depth in shorter span by assuming some diameter. Then we calculate the load calculations which are coming, the self-height of the slab and the floor finishing and everything. Then the here the stiffness calculation is an extra portion. The step 3 itself is a big thing where you calculate the stiffness of the slab, and it is given in IS quarter provisions along longer direction B dq by 12 in along longer direction, and for slab it is taken as 4E by L. We calculate the stiffness for slab, we calculate the stiffness for column, and the we calculate coefficient in longer direction, and we calculate the same stiffness, same these things for shorter direction. The only here the change is the values here. So here uh, we need to have some changes here. When you are having in longer direction, we'll take shorter span, and we are calculating for a shorter direction, we take the longer span. Now, these values are changing here. The numerator goes denominator, denominator goes numerator, and we summation these values and we'll keep it this aside. So this is the alpha c value, the factor in longer direction, and this is the value in shorter direction. So uh, then there is stipulation saying that if the live load ratio and dead load, if it is less than 0.50, then pattern of loading is also should be done, and if it's greater, there is nothing to do all these things. So as because we have got greater value, then you have to check the pattern of loading for longer direction and the same way for the shorter direction. So and it goes like this. So we need to calculate the L2 by L1. L2 is a shorter direction, L1 is a longer direction panel length. Then this is the these values. So you need to from table 7, it looks like this from IS456. So you need to calculate for L2 by L1 0.75 value. What is the alpha minimum value? And you'll get some alpha C minimum value, right? So if alpha C minimum if itself is that, and when you have calculated alpha C from a previous, which you have got a greater value, then the pattern of loading should be constant and the correction shall be done. So here itself also in the same way we have got the same thing here. So in the design movements, what we do is we calculate that aside and we'll put it aside, and these values will put. So when these values are there, then the coefficient correction value should be calculated. And this is a whole big formula we have to substitute from page 66, page 456, the 1.1, and this will come in the next uh, procedure. So we calculate the design movements, which is the formula given in IS 456 2000 in this class, WLN by 8. So we calculate W for short direction, longer direction, we calculate W in longer direction using that formula. The only thing L changes here, and this comes to this, and this comes to Ln is the spacing, intermittent spacing between the columns. So then we divide the entire slab into column strip and middle strip. Then we have this big table. It's a bit hectic, but by practice we can have this all. So first thing is the minimum percentage of steel for any slab we have to remember is that is a 0.4 percentage. So we need to remember these values, right? So minimum percentage of value here I've written here. This is the 0.12, and if you are getting less than that, minimum percentage should be given to it. So along long direction we make a table. Then we divide into column strip and middle strip. And in column strip we have positive, we have negative, positive, negative. And we'll write down the values of this zero point 0.6 into 0.35. 0.6 is the factors which you get from the code book, and the 35 also factors which you get from the code book. So 0.65, these are all factors which you get from the code books. And we when we have these values, we calculate this still using this formula. We calculate the per meter, and this will check these values with minimum percentage, minimum area of steel. Because this is less, we directly substitute 472.5. So in this way we calculate the reinforcement for the longer direction, and in this way we calculate the reinforcement in shorter direction. So after calculating, we just detail it, and show sectional and plan. So thank you. We'll get in detail in the next class.